Greetings, welcome to the Get Solution India. In this lecture, we will discuss some questions on the amplifier design, BJT based amplifier design. So, this is the first question. The question is given for the DC analysis of the common emitter amplifier. DC analysis करना है. DC analysis. Okay. So, for the DC analysis of a common emitter amplifier. Okay. So, in the DC analysis, we always do the DC analysis for all the amplifiers, because first we find out the gain of the amplifier. So during the gain of amplifier we need a IC current, okay, and threshold BT voltage, okay. So that's why we use the DC analysis. So first DC analysis of the common emitter amplifier, neglecting the base current. So we is telling about IB is very less, okay, so we can neglect this IB. If we neglect the IB, so we know that IE is equal to IC plus IB. If we can neglect this IB, it means IE is equal to IC. So he given IE is equal to IC, and again he clarify the same thing. If he will not discuss about collector current are equal, so we can already assume I is equal to I, but he is clarifying in this question, collector current and emitter current are the equal. So again he is clarifying that the collector current and emitter currents are the equal. So don't worry about this, but this is the key point of this question. The base current is neglecting and collector current and emitter current are the same. Okay, so this is the key point of this question. It means I is equal to IC. So he given that I is equal to IC. Okay. Next thing is that he given the threshold thermal voltage BT 25 millivolt. Second, he given the BBE is equal to 0.7 volt, and he asked the BJT output resistance RO is the infinite. He is telling about the early voltage VA is equal to infinite. That's why RO is equal to infinite. Okay. So we can neglect R. That's why he written here. Now then find the gain. तो हमें gain find out करना है. ये gain हमें find out करना है. तो सबसे पहले तो हम now first we will see this circuitry. Okay. How this circuit is look like. This circuit look like this is the emitter resistance. Okay. This is the collector resistance. This is collector. This is emitter. This is base. Okay. And this is the voltage divider biasing, and here we are applying the input voltage, and some capacitors are here. Okay, so given a capacitance with the capacitance values. So during a gain calculation in the DC analysis, is it required these capacitors? No, because the gain of this first we will see how this circuit is look like. When we calculate when we can simplify this circuitry. How can we simplify it? Just we calculate the Thevenin equivalent resistance and Thevenin voltage of this input circuitry. So it is look like this is the RC resistance BO, okay, with some voltage 12 volt, and it has equivalent resistance RTH, it has equivalent voltage VTH, and it given a input voltage Vs, and there is a emitter resistance 2K is equal to 0. Now how it is look like, and something RL is also given RL, and we need to find out BO here. So now this equivalent circuit is how it is look like. It is look like a common emitter stage with degenerative feedback with the emitter resistance. Now we need to find out the gain of this stage. And we know that what is the gain of this stage. So first we need to find out the gain, and the gain of this stage is equal to AB minus GM R equivalent output resistance. Here output resistance is equal to RC into RL. So the parallel combination of RC RL by 1 plus GM RE. So this is the formula for the gain of common emitter amplifier with the degenerative feedback or RE resistance. So how can we calculate this gain? So first for a gate we need to remember this formula. Okay, if somehow if we forget this formula, so first we draw a small signal model of this circuitry. So first we will draw the small signal model of this. This is the first step of the transistor. So first we draw the small signal model of this transistor. So this is the small signal model of this transistor. After this we grounded all the voltage source. So first we ground this voltage source, okay, and short this and it means we short all we replace all voltage source and current source by their internal resistance. So the internal resistance of voltage source is ideal voltage source is 0, so it will short and this is grounded. Okay, so after that we will put all the elements. Okay, so at the emitter side, this is the emitter, base, this is collector, this is emitter. So at the base side, okay, at the base side there is the RTH, so we will put a RTH here. So this is the RTH, okay, and there is no voltage source, okay, only input source PS is given. At the emitter side there is a 2K RE resistance, this is 2K RE resistance, so this is 2K RE resistance. After that there is the parallel combination because this is also grounding at that node and this is also grounding through this node. So this is the parallel combination of RE and RL, RC and RL. So this is the small signal equivalent model of this circuitry. Okay, so during the gate examination, don't waste time to calculate the AV. You need to remember this formula. But somehow if you forget this formula, so you can easily calculate here. Now how can we calculate the gain of this? We need to calculate the gain, means AB is equal to BO by BS. So we need some expression in the terms of BO and BS. Okay, so during the calculation, first we calculate the value of B pi, this B pi. Okay, because this GM is depend on this current source is depend on GM into B pi. So we need to find out the value of B pi. So to calculate the B pi, first we calculate the KCL here. During the KCL, we can easily find out the value of B pi, and this value we will put here, and we apply KVL here. So KVL here we will apply the KVL. In this way we can calculate the gain. So in this way we can calculate the gain from this circuitry. You can how can we calculate the gain of this circuitry? You can find in my last lectures the common emitter configuration with degenerative feedback. So from their lecture you can easily find out how can we calculate gain of this circuitry. So this is the gain of this circuitry. Now next step, what are the given quantity in this formula? So RC is given, this RC is given, RL is given, RE is given. So RE is here, RC is here, RL is given. So all are given. We need to find out the GM. So what is the formula for GM? We know that the formula for GM is equal to IC by VT, this thermal voltage, and this thermal voltage is given here. So this is the given quantity. Now we need to calculate the IC. Okay, so how can we calculate the IC? Through this circuitry. Okay, or we can calculate first. So during the calculate the IC, we need to find out the value of IB. Because we know that IC is equal to beta times IB. But in the question, he says that neglecting the base current. If we neglect the base current, okay, it means from this formula, this IC is equal to beta. Okay, but beta is not given. So how can we calculate the IC? But he given that this IC is equal to IE. Okay, so if this IC is equal to IE, so we can calculate, if we are able to calculate this IE, so we can calculate the IC. Yes, we can calculate IE here. We can calculate IE here. Okay, how can we calculate the voltage at this node? The voltage at this node and voltage between this divided by this. So we can calculate IE. So we know that IE is equal to, we need to calculate the IC. And we know that the I is equal to VTH, the voltage at this node VTH, this VTH, this is the VTH, previously it was VTH here. So VTH minus VB by RE. Now, what is the value of BTH? We need to calculate the BTH from this circuitry. So, how can we calculate the BTH here? This voltage multiply by this resistance by total resistance. Threshold Thevenin equivalent voltage. So, Thevenin equivalent voltage BTH is equal to this 47 into 10 to the power 3 because it is in K into 12 volt by 47 into 10 to the power 3 plus 73 into 10 to the power 3, it is equivalent to 47 into 12 into 10 to the power 3 by 120 into 10 to the power 3. This 20 to the power 3 will cancel out, so this will go in 10 times. Okay, so here we can calculate the BTH is equal to Thevenin equivalent voltage 4.7 volt. Okay, so just put the value of BTH here. Okay, so we can calculate IC. IC is equal to 4.7 minus 4.7 by RE. RE is the 2K given 2K. So put the value of 2K here, 2 into 10 to the power 3, and VB is also given here. This VB is also given. So from here we can calculate the value of IC is equal to 4 by 2. It means 2 milliampere. So this value is 2 milliampere IC. So IC is given. Now we can calculate the GM. So we can calculate GM here. GM is equal to IC 2 into 10 to the power minus 3 by 25 into 10 to the power minus 3. This will cancel out. So 2 by 25 is the GM, 2 by 25, it is the GM. Correct? So GM is given. Now we can calculate the AB. Yes, now we can calculate the this AB. Okay, so this gain, we can calculate gain here because all the quantity is given here, because previously this GM was unknown, now this is the known quantity. So now gain AB is equal to minus, what is the value of GM? 2 by 25 into the parallel combination of these two resistance RC into RL. RC is equal to 2K, 2 into 8K, 8 by 2 plus 8 into 10 to the power 3 by 1 plus GM 2 by 25 into RE is the 2K, 2 into 10 to the power 3. Okay, now easily we can calculate total calculation. You can do the whole calculation and you will get AB is equal to 128 minus 128. So this is the gain of this amplifier. So we are able to find the 128. This is the answer of this. So what we learn from this question? The first thing is that first we need to always we think about first we need to calculate the gain, and gain we know the gain is minus GM RC parallel with RL by 1 plus GM into RE. So we need to calculate the GM, and we know that GM is equal to IC by BT. So we need to calculate the IC. So to calculate the IC we need a beta current, base current, because we know that IC is equal to beta into IB. But he said that the IB is neglected, so that we find that the IE is equal to IC. If IE is equal to IC, so we can easily find out the IE here. If we know the voltage at that point, this voltage minus this voltage, in this way we can calculate is the BE voltage. Okay, so BE voltage by resistance is equal to RE, because we know that BIE is equal to BE minus divided by RE, and B is the voltage at that point. So this voltage minus this voltage. So first we need to find out the BTH minus BB voltage divided by RE. So in this way we can calculate the IE. If IE is known, so this is equal to IC. If IC is known, so we can easily find the IC by BT. Okay, so GM is, so we can calculate GM, and when we put all the values here, and we get gain is equal to 120. Thank you very much.